Today we're going to talk about how we solve an equation that contains absolute value. You may remember from a way long time ago, back in Algebra 1, that we talked about this concept of the absolute value of x. The way we denote absolute value is with these two straight bars on either side. And what absolute value represents is it represents the distance from 0. We would say that both the absolute value of 3 and the absolute value of -3 are equal to 3. Because what this is asking, if I want to know the absolute value of 3, that's saying how many steps from 0 is 3? Well, it's 3 spaces away to the right, but we only count distance in positive units, so it's 3 units away from 0. Similarly, -3 is also 3 spaces away from 0. Even though we're counting to the left, we don't consider distance to be negative, which is why the absolute value of -3 is also +3. What's really important to notice here is both +3 and -3 have an absolute value of +3. Okay, here is how we interpret absolute value equations. Like we just talked about here, if I were to say that the absolute value of, let's say I did not know that the answer was 3 or -3, what if instead I gave you an equation that said the absolute value of x is 3? Another way that we could think about this equation is saying what number is 3 units away from 0? Well, there's two possibilities here. We could either count to the right or we could count to the left, so we get two different solutions. X could be +3 if I were to count 3 units to the right, but if I were to move 3 units to the left, we could get an answer like -3. And that's really what this whole box right here is talking about. Anytime we set something up, it's talking about a distance. In this example here, I'm not adding anything to my x, and so it's just the absolute value of x, in which case we'd be adding or subtracting a 0. We interpret it a little bit differently if we add something else in. If I say the absolute value of x minus b equals k, then instead of counting the distance from 0, we're now counting the distance from b. It's really pretty much the exact same idea. So here's what I want us to look at. How do we then apply this idea to be able to solve absolute value equations? Well, here are the steps. And these you probably want to have in your notes. If we want to solve an absolute value equation that is in the form of ax plus b absolute value equals c, then we can go ahead and set up this equation. Since we can either count to the right or the left, we have to set up two different equations that are going to account for that. So the first equation we would say is that ax plus b equals +c. That would be if we were counting to the right. But remember, counting to the left is also a possibility, so we have to set up one where we're also counting to the left, which would make it negative. Then we solve the equation one at a time and see what our answer is. You should get two solutions to every single absolute value equation. Let's look at a couple of examples. All right. The absolute value of x minus 5 equals 7. Here are our two possibilities. If I'm counting to the right, that would take me to +7. So I would solve the equation x minus 5 equals 7. If I count to the left, that should take me to -7. And so here I just have two different possibilities. We're going to treat them each differently, solve them one at a time. Here we would add 5 to both sides and we would get x equals 12. Here we would add 5 to both sides and get x equals -2. Both of those are going to give us a distance away of 7. If we do a quick check here, if I do 12 minus 5, that's going to give me the absolute value of +7, which equals +7. But -2 is going to give me negative 2 minus 5, which is negative 7, and that also equals positive 7. So that one checks out as well. This is why we're getting two different solutions. Okay, number 2, we would set up very similar. See if you can decide what the two equations would look like and write those down on your paper. The first one would say 5x minus 10 equals positive 45. The second one would look, almost exactly the same, except instead of positive 45, it would be equal to negative 45. And now we solve those in exactly the same way. This one has more steps, but that doesn't matter. If we add 10, we get 5x equals 55. So x equals 11 is our first solution. And here we get 5x equals negative 35. So x equals negative 7 is our second solution. Okay? Just a side note, you cannot do this step of writing it as two equations until the absolute value term is by itself. Occasionally, we might see something like 2 times the absolute value of 4x equals 16. Well, our first step before we could set up two equations would have to be to divide by 2 on both sides because the absolute value was not alone. Then from here, you could set up your two equations and solve. Okay? What I'd encourage you to do is go ahead and put the video on pause at this moment and try to solve number 3 on your own so that you can check if you're on the right track. Once you've checked, then go ahead and push play and you can follow along with my answers. The two equations you should have set up for this one are 3x minus 2 equals positive 13 and 3x minus 2 equals negative 13. When we solve this, we're going to add 2 to both sides. So we get 3x equals 15, and therefore x equals 5. And then we get 3x equals negative 11, and therefore x equals negative 11 thirds. And that, again, is perfectly fine to leave like that. Okay? The last thing that I want to point out, and we're only going to do one of these, but every so often it is possible that even though you have done all the math right, you get a solution that is not viable. This happens quite frequently when we have a variable that is outside of the absolute value. This is the first of many times that we're going to see something that might yield an extraneous solution. Extraneous means kind of just what it sounds like. It means extra. It's there, but it's not actually one that we can use. And so here's an example of that. We would set this up to work the problem exactly the same way. One positive, one negative. So I would say that 2x plus 12 could be positive 4x, or 2x plus 12 could equal negative 4x. So let's solve both of these and see where we get. We subtract 2x from both sides and then divide by 2, so we get that x equals 6. Over here, we would subtract 2x from both sides, and we get 12 equals negative 6x. So in this case, x could be negative 2. Here's what happens if we go and plug those answers back in. Okay? If I plug in positive 6, I get the absolute value of 2 times 6 plus 12 equals 4 times 6. That would be the absolute value of 24 equals 24. This is going to work because the absolute value of 24 is 24. However, look at the second one. If I say 2 times negative 2 plus 12, absolute value, is equal to 4 times negative 2, I get negative 4 plus 12, that's the absolute value of 8 equals negative 8. If you don't see the issue yet, here's what's going to happen. The absolute value of 8 is 8, but I see that it's supposed to be negative 8. That's not possible, so that means that this solution is extraneous and I only have one good solution. The only time you would need to check for that is if there's a variable that is outside of the absolute value. That's when the rules about having to stay positive don't necessarily hold, and sometimes we need to do a double check. All right, that is it. You have an assignment to work on. If you have questions, shoot me an email. Thanks.